Hello guys, how are you today? So today I'll be explaining the Math AMS quiz of term 2, week 2. Now, I did not explain anything for term 2, week 1 because it was all final materials. This you guys should have done it by yourselves. But now I will be explaining the Math AMS quiz, even though for the students in UAE, I believe we do not have a Math AMS, but for some students outside of the UAE, yes, they do have an AMS, so I'm gonna explain it either way. Now, we're gonna start with the first question. The figure above shows the graph of a cubic function f. Which of the following could be the equation of this function where k is a constant? The very first thing we need to know is that when we look at this, they are talking about the x-intercept. So what do they mean, first of all? We're going to take each function by itself and explain it. First thing they are telling us is that function x is equal to constant k, x minus 3, x squared minus 9. What's going to happen here is that you're going to take both of these and you're going to solve them. So how do you solve them? You're going to take x minus 3 equals to 0 and x squared minus 9 is equal to 0. So then solving it, you're going to get the solution x is equal to 3. And here, x is equal to plus or minus 3. So this is the equation for the first one. What does this mean? When we're talking about x, we're talking about the x-intercept, meaning where the graph, okay, I'm just gonna write graph meets x-axis. We call this the x-intercept. So when we're talking about the x-intercept, we're gonna solve it. And for this one, we got two values, more than one value. We have x is either equal to 3 or x is equal to plus or minus 3. We already put plus 3, so minus 3. So that means the x-intercept should be at two places. But my question is, if you go up, do you see that the graph meets the x-axis, this over here, at two places? No, it does not. That means the first one is incorrect. In fact, to make it easier for ourselves, look what we're going to do. We're going to go here on the x-axis. We're going to choose this point over here where the graph meets with the x-axis, and it is at minus 3. So we know the x-intercept is only at negative 3. Okay? So when solving, we should get an x-intercept of only negative 3. Let us solve the next one. We have x minus 3 and x squared plus 9 equals to 0 equals to 0. Solving this one, you're going to get x is equal to 3. And solving this one, you're going to get no answer or no real root. We're just going to say no real root for now. Not no answer, we're just going to say for now, no real root. Okay? So our x-intercept is either at 3 or actually only at 3. But is our x-intercept at 3? No, our x-intercept is at negative 3. So that means this is also incorrect. Moving on to the next one. Okay, we have here x plus 3 equals to 0. X squared plus 9 equals to 0. Solving, you're going to get for the first one, x is minus 3. And for the second one, you are going to get x is actually, there's no x. There is no real root. Great. So we found one that has a single root, which is minus 3. So it's this one over here. Now this one is a very good trick they put here. If you solve it, you're going to do x plus 3 equals to 0, x is minus 3. Oh, this one also is, let me just write it, x plus 3 equals 0, x equals to minus 3. Oh, this one also has an x-intercept of minus 3, but we do not choose it. Why don't we choose it? We don't choose it because, look, it is to the third power. That means it's 3 roots. It has 3 roots, okay? So now we have two conditions to apply. Whenever we solve a question like this, first thing, you have to make sure that it is only to one root make sure to one root. This is only if we're solving a question like this that has one x-intercept. So we're going to talk about one x-intercept. We have to make sure there is one root, so it's to the power of 1, so x to the power of 1, this we consider. And second thing, it has to be the x-intercept. Now, if it's to more than one root, we will discuss this later on. But so far, all we can say is that when solving this question, we're going to check first of all, what is the x-intercept? We're going to solve for the x-intercept. When we find it, we're going to choose it, and we have to make sure it is to the power of 1. Now, moving on to the next one, this is a very nice and easy question. They told us sine theta is equal to radical 3 over 2. Which of the following could be equal to theta? Very simply, to find out what theta is, we're just gonna substitute 180 and do sine our answer. So how are we gonna do it? We're gonna start with the first one. We're gonna put on our calculator sine. We're gonna put 7, and instead of every pi, we are gonna put 180. So 7 times 180 over 3. And if you do it, it is radical 3 over 2. So this is an answer, an option. Then the next one, if you're going to do sine 180 over 3, because you replace pi by 180, you're also going to get radical 3 over 2. Then if you do sine minus 180 over 3, you're going to get minus radical 3 over 2. So we're not going to choose it. But then if you do sine 2 times 180 over 3, you are going to get radical 3 over 2. And then finally, if you're going to do sine minus 2 times 180 over 3, you are going to get minus radical 3 over 2. So for this one, we have 3 correct answers, which are these. Basically, how to solve this type of question, what we are going to do is we're going to do instead of, so if we have sine, we're going to put sine, okay? And then on the calculator, instead of the pi, we're going to put 180, and then we will solve. Now we move on to the next one. This one will take some time. Why? They're telling us which of the following have a graph that is symmetric about the origin. Symmetric about the origin means it is odd. So we have to search for which of the following is odd. In other terms, symmetric about the origin means odd. So now if we are going to proceed, we are going to start with the first one. If you remember, to find out if something is odd, the only thing we have to do is that fx has to be equal to minus f minus x. What does this mean? Very simple example. If we're doing x plus 2, is this an even function or an odd function? No, let's do it x plus 2x to the power of 3. Okay, great. Is this an even function or an odd function? Let us check. First thing, if we are going to substitute the x by 1, instead of x put 1, we're going to have 1 plus 2 to the power of 1 to the power, it's 1 plus 2 times 1 to the power of 3. If you do it on your calculator, you're then going to get 3. Now, this 3 has to be equal to minus f minus x, meaning minus, now instead of x being 1, we're going to put it as negative 1. So now it's going to be minus times minus 1 plus 2 times minus 1 to the power of 3. If you do it on your calculator, minus, open brackets, minus 1 plus 2 times minus 1 to the power of 3. Don't forget to close your bracket. You are going to get 3. So definitely 3 is equal to 3, so this is an odd function. So we are gonna play it like this, or we can do it in another way. So let's start with the first one. Y is equal to x to the power of 3 over x to the power of 2 plus 1. How do we know if this is odd or even? Very simply, choose a number, okay? We have y means fx, so our fx is equal to x to the power of 3 over x squared plus 1. very simply what we are gonna do is we are gonna substitute the x by 1. This is our first starter. Substitute the x by 1. So then we are gonna get, it is 1 to the power of 3 over 1 to the power of 2 plus 1. Okay, and if you do it on your calculator, you are then gonna get 1 over 2. So that means fx is equal to 1 over 2. What about minus f minus x? Let us find out. Okay, so if we're talking about minus f minus x, that means we chose 1 for x, we're going to choose minus 1 now for minus x. So it's going to be minus 1 to the power of 3 over minus 1 to the power of 2 plus 1. If you do it on your calculator, you are going to get minus 1 to the power of 3 over minus 1 to the power of 2 plus 1. You're going to get negative 1 over 2. But we did not finish yet. We said minus f minus x. So we're going to multiply all of this by minus. And then we're going to get 1 over 2. So 1 over 2 is equal to the original one, which was 1 over 2. That means this is an odd function. Next step, okay, is x over x squared plus 1. What we're gonna do is very simply substitute again. So I'm gonna do it faster this time. So to find fx, I'm gonna choose x as 1. It's gonna be 1 over 1 squared plus 1, which then gives us 1 over 2. However, if we're choosing minus f minus x, it's gonna be minus 1 over minus 1 squared plus 1, which then gives us minus 1 over 2, but then we need to multiply it by minus. So times minus, it gives us 1 over 2. This and this are equal, so that means this is an odd function. Now, after solving this, we can derive a rule, but it's going to be a little bit complicated. I will explain the rule at the end of solving this question, but I prefer you do this method because it's easier and it's more accurate. Again, I'm going to do this but faster. Fx is equal to 1 squared over 1 squared plus 1, so that is 1 over 2. Then minus x is going to give us then 1 minus 1 squared over minus 1 squared plus 1, and then it's going to give us 1 over 2, but then we have to multiply it by minus, and it gives us negative 1 over 2. And then we notice that this and this are not equal, so that means this is not an odd function. Now, moving on, we have this over here. So very simply what we need to do is substitute. So fx is equal to 1 over 1 squared plus 2 times 1. This gives us 1 over 3. Now minus f minus x is equal to minus 1 over minus 1 squared plus 2 times minus 1. And this is going to give us minus 1 over minus 2, which is then 1 over 2. And as you can see, this and this are not equal. So that means this is not an answer option. Okay? Now, moving on to the last and final one, it's a very simple one. Fx is equal to 2 times 1 over 1 squared plus 1. This is going to be 2 over 2, which is 1. Then, if we're going to do minus, it's 2 times minus 1 over minus 1 squared plus 1. That's minus 2 over 2, which is then negative 1, but then we multiply it by minus, and we are going to get then 1, and 1 is equal to 1. That means this is an odd function. Now, the rule I wanted to state was that very simply, if you see an x squared or like everything, okay, this is the rule I'm going to state. I believe it's going to help a little bit, but not too much. What you guys can do is that if you see in the function, all of the powers or the majority of the powers are even. Not majority, actually, they all need to be even. All need to be even. So anything that has a power has to be an even power. Okay? Meaning, for example, here we have x squared and x squared. They are all even powers. That means it is then not odd. Now, of course, this will help you to identify it quicker, but for the ones that have even power and odd power, I prefer that you substitute. Otherwise, if they're all even powers, then you know it's not odd. Now we're gonna move on to the next question, question number 4. Now this is nice. Which of the following has a graph that is symmetric about the y-axis? Look, this is the y-axis over here. So if it's symmetric, let's take a parabolic function, for example. Symmetric about the y-axis, that means it is even. So this is what an even function would look like, whereas an odd function would look something like this. All right? So now they're telling us, okay, symmetric about the y-axis, this means even. So very simply, to find out if it's even or not, we can do something nice. Not only nice, but also really simple. So just by looking at it, see which ones do not have an even exponent. If they do not have an even exponent, it means they are not even. So look at this one. This has even exponent, but it also has odd, so we do not take it because they all have to be even exponent. Look at this. The x has, it is to the power of 1. It does not have an even exponent, so we do not take it. This one, however, we take it. Why? Because it has only 1 power and it is an even power. This one, we do not take it because it has to the power of 3, which is an odd power, which we do not need. We will not take it. And now finally, we take this one. Why? Because both of the powers are even. And like everything that we have, all the exponent is even, so we will take it. Okay, now the even is much simpler if you apply it like this. Of course, if you want to double check, please do substitute to double check. Now we reach something nice, something really like makes you think. Okay, it's not really too much of thinking, but just like it opens your mind a little bit. So what we need to know is that 1 plus tangent squared of x is equal to secant squared of x. Knowing this, you can apply everything and you can solve everything really simply, really easily. So first thing we're gonna do, we're gonna keep this in mind and then we will proceed. Now, what is the value of k if secant squared x minus 22 tangent x plus 20 is equal to 0 is reduced to tangent x equal 1 or tangent x equal to k? They need us to find this, meaning they told us they found one of the roots, they need us to find the other root. Very simply, what we are going to do is we're going to look, okay, can we replace the tangent with anything? Because you cannot have secant and tangent in the same expression. They have to be everything the same. So if you have sine, everything should be sine. Cosine, everything should be cosine. Tangent, everything should be tangent. Secant, everything should be secant. So if we have tangent and secant, this is not going to work out. What we're going to do instead is we're going to see, can we change the tangent into secant? No, we cannot. We do not change this, we have to keep it the same then. But then can we change the secant squared x into tangent squared x? Yes, very simply. So now the equation is retransformed into 1 plus tangent squared x, okay, minus 22 tangent x plus 20 is equal to 0. Now you solve it. After solving it, it's gonna be tan squared x minus 22 tan x, and then you add 20 and 1, you're going to get 21 is equal to 0. Now, what we are going to do is we are going to treat these as an x. So it's going to be technically x squared minus 22x plus 21. So it's like you are cancelling out the tangent. Then it's retransformed into x squared minus 22x plus 21. Now let us find the roots. Very simply, you can do it by the product sum method, mentally, whatever, or you can use the calculator. I don't know if you can do this on your calculator, but on your calculator you do mode 5, 3 for second power equation. So mode 5, 3, and you get it to second power equation. Now what's the coefficient next to x? It is 1. So we are gonna put for A 1. For B it is negative 22. And then for C it is 21. And then putting it on the calculator, you are gonna get that x is 21, or before doing anything, you're gonna press equal again. You're gonna get x is 1. And that's it. To return to normal, just do mod 1. So now you have the root is either x is 21 or x is 1. So they told us 1, then for the other one, we're gonna put 21. Now we move on to the next one, question number 6. The symmetric image about the origin of the point P minus 6 minus 8 is the point P prime. Okay, this is a very interesting thing. When they're talking about the origin, remember, symmetric about the origin means odd. And in odd, all changes, the x and y changes. But however, if they are talking about symmetric about the y-axis, that means it's even, and in the even, only x changes. So since we are talking about the odd, then everything changes. What do we mean by changes? That means only their sign changes. So it will stay in the same position, but only the sign is changing. So minus 6 becomes 6, and minus 8 becomes 8. Now we move on to question number 7. They need the vertical asymptote of the graph. Okay, very simply, to find the vertical asymptote of the graph, remember, vertical asymptote, what we are gonna do, if they give it to us in this form, we're gonna take this denominator, okay, and we're gonna solve it. So for x minus 40 is equal to 0, bring 40 to the other side. For x is equal to 40, x is equal to 10. And like this, we found the vertical asymptote. So remember, vertical asymptote, you solve the denominator. In this case, it's gonna be 10. Moving on to question number 8. Okay, this is a big one, full explanation one. Horizontal asymptote. When we are talking about the horizontal asymptote, this means first thing, we're gonna factor these, okay? See how can you factor them. You're gonna get y is equal to, factoring the first one up, it's gonna be 8 times x plus 120 divided by 8, 15, over 2 times x minus 2. Now the horizontal asymptote is very simply these two numbers divided by each other. So 8 divided by 2, which is 4. Vertical asymptote, as we said, we are going to solve the denominator. So we're going to take this, x minus 2 equals to 0, so x is equal to 2. So like this, we found the horizontal asymptote, which is 4, and the vertical asymptote, which is 2. Okay, so 4 and 2. Now moving on to the y-intercept. Whenever we are talking about the y-intercept, this very simply means that you take it back into its original form. How is it? It's put like this, so you're going to take it originally, and you are going to divide these two numbers by each other. So you're going to divide. You're going to leave the numbers with x alone. They will stay by themselves. And then you are going to divide these two numbers by themselves. So that becomes 120. Divided by minus 4, this gives us minus 30. So this is the y-intercept. Now to find the x-intercept, or it crosses the x-axis, which is basically the x-intercept, what you are going to do is you're going to take the numerator and you're going to solve it. So it's going to become 8x plus 120 is equal to 0. 8x is equal to minus 120, x is equal to minus 15. Now that we solve this, let us remember the rules again. Horizontal asymptote. To find the horizontal asymptote, what we are going to do, we are first going to factor, then divide. Okay. To find the vertical asymptote, we are going to solve the denominator. Okay. To find the y-intercept, you are just going to divide the constants. What are the constants? They are the numbers that do not have x, y, or anything like this. And finally, to find the x-intercept, solve numerator. Okay? Now we move on to question number 9. Here they are talking symmetry about the y-axis. We said symmetry about the y-axis is what? It is even. And when we are talking about even, okay, and we said when we are talking about even, only the x will change. So the positions are the same. It's also 6 and 8, but only 6 will change its sign. If it was negative 6 before, it's gonna become positive 6, and negative 8 will stay negative 8. Now we move on to question number 10. Okay, so what we are gonna do here is we are gonna also know one more equation, which is that cosine squared x is equal to 1 minus sine squared x. Okay, it can go both ways. Also that sine squared x is equal to 1 minus cosine squared x. Looking at this equation, we see we have sine and cosine, so it's not going to work. They both have to be the same thing. So for them to both be the same thing, we need to see which one. Can we change? Can we change sine? No, we cannot, so we don't choose it. Can we change cosine squared x? Yes, we can change it to sine squared x. So before changing it, let's move it to the other side. It's going to be 1 plus sine x plus cosine squared x is equal to 0. Now change cosine squared x into 1 minus sine squared x. So 1 plus sine x plus 1 minus sine squared x. And then you have to rearrange it into order. It's going to become minus sine squared x, okay, plus sine x plus 2. Now, to solve it on the calculator, you go mod 5, 3. So mod 5, 3. For A, you are going to put minus 1. For B, you are going to put 1. And then for C, you are going to put 2. And then you're going to get two equations. So x is equal to 2 or x is equal to minus 1. They already gave us minus 1, so we are going to put 2. Moving on to question number 11. This is also, we're going to apply that cosine squared x is equal to 1 minus sine squared x. So they told us sine x is 3 over 5. Okay, what is the value of k if cosine squared x is k over 25? Very simply, substitute cosine squared x by 1 minus sine squared x. And we know that sine x is 3 over 5. That means sine squared x is going to be 3 over 5 squared. So in other terms, it's going to be 1 minus 3 over 5 squared. If you do it on the calculator, it's going to be 16 over 25. So that means the value of k is 16. So our answer over here is 16. Moving on to question number 12. Okay, also again, secant squared is equal to 1 plus tangent squared. Don't forget the x. Now, tangent x is 7 over 5. What is the value of secant squared x? Substitute. 1 plus tangent squared x is equal to k over 25. Okay, 1 plus tangent x is 7 over 5. So very simply, you can do it 1 plus 7 over 5 squared. If you do it on the calculator, you are going to get 74 over 25. So the value of k is then 74. Moving on to question number 13. Here again, we have that cosine squared x is equal to 1 minus sine squared x. So substitute it here. It becomes 160 times 1 minus 3 over 8, because we know sine squared x is 3 over 8. Doing it on your calculator, you are going to get 100. So very simply, the answer over here is 100. Moving on to question number 14. The graph below displays the cumulative frequency for data collected on the number of raffle tickets sold by a group of 200 students. They told us to the nearest multiple of 10, the lower quartile. What does lower quartile mean? Lower quartile means 25%. So very simply, on your calculator, you do 25% of the total raffle tickets sold, which is 200. So 25% times 200, you're gonna get 50, but we do not put 50 as our answer. We go to the cumulative frequency, okay? And we find out for which cumulative frequency is it 50, and it turns out to be 70. So for 70 tickets, this is the lower quartile. Now for the upper quartile, it means 75%. 75% times the total tickets sold, which is 200. So doing 75 over 100 times 200, this is gonna give us 150. So we're not gonna put 150 as our answer. Instead, we're gonna go to the cumulative frequency, choose 150 as our answer, and we are gonna get it approximately 110. Now finally, for the interquartile range. Interquartile range means the upper quartile minus the lower quartile. So very simply, 110 minus 70, and we are gonna get 40. Okay? Now, moving on to part B, the median number of tickets sold. Median means half. Now, since it is a graph, we are not gonna add 1. A graph is very accurate. So remember, if it is in a table, you are gonna add 1. If it is in a graph, however, you don't need to add 1. Directly, you take what is half of 200, it is 100. Now you check in the cumulative frequency, 100, and it's over here. And it is between 100 and 90. So the answer is between 90 and 100. Now they need the 95th percentile. What does this mean? That means 95% times the total tickets, which is 200. 95 over 100 times 200, this is 190. So now we go to the cumulative frequency. We choose 190, which is this point over here. Okay. Then we're gonna go down, and it is approximately 160, I believe. So our answer over here is 160. Moving on to question number 15, they're asking for the mode. The mode means the most repeating number. Here, since there is no intervals, we can assume directly that the mode is the most repeated frequency, or the highest frequency. Looking at it, which one has the highest frequency? This one over here. So the mode of the number of pets per household is 2. Now question number 16, here we have intervals. What do we do when we have intervals? First thing we're gonna do, we're gonna take the frequency and we're gonna divide it by the width to find the frequency density. So to make sure the model class, which one is being repeated more, we're gonna take the frequency divided by the width to find the frequency density. So to find the width here, it is 10. It's 10 minus 0. Here it's 40 minus 10, which is 30. 60 minus 40, 20. 90 minus 60, 30. 100 minus 90, 10. So that means the first one is 10 divided by 10. So the frequency density for the first one is 1. 30 divided by 30, 1. 40 divided by 20, 2. 20 divided by 30, it's 2 over 3. 30 divided by 10, it's 3. So looking at them, which one has the biggest frequency density? It's definitely the last one, between 90 and 100. So we choose it as the one of the model class with the most repeating distribution. Now here, this is a trick. Look, 150 minus 140, if you find the width, it's 10. Here it's also 10 and 10 and 10. So instead of dividing them to find the frequency and density and whatever, if they all have the same interval, just choose the one with the biggest frequency, and it's going to be 150 and 160. So let's submit, and hopefully we do not have any mistakes. And thank God we do not have any mistakes. Thank you guys for watching and have a wonderful day. And for those who have a vacation, have a wonderful vacation.